quiz 7, I mean, a large oh, come on, you're always late. Why is that?
Sorry.
Right. Can you listen to me? First of all, I mean, many of you are handing in just towards the time, which I mean is highly unappreciative of the amount of work I have to put in. Yeah, I hope next time don't try to put things in to the last minute. All right? Well, nobody does this at the university, marking 400 papers and scanning them and returning them to you on the same day. All right, so please try to take that into account next time. Now, quiz 7, I'm really disappointed with, I mean, I did 10 examples on MLEs alone, right? And I gave you the rules for dealing with products, dealing with sums, and so on, right? And yet you can't, many of you, I mean, many had problems. I mean, I have been having trouble marking this because I mean, when you write down the likelihood, right, it's the likelihood of the product from I from 1 to n of, are you listening or what? Yeah. Of lambda xi minus 1 so it's already late, sir. So I mean, I told you many times. Please, I won't accept next time. Please try to be appreciative, guys, please. You write it like this, okay? Now, I gave you rules for simplifying products like this. And all you have to follow, just simply follow the rules. And it seems many of you still can't follow the rules. I mean, this is mathematics. It's nothing to do with statistics. This is stuff you should have learned in your, I don't know, your A-levels or first, I don't know what course teaches this kind of stuff. But still, I mean, out of the way, I went out of my way and gave you the rules for simplifying sums. It seems, okay, well, it seems you can't. I mean, I don't know what the problem is. I mean, how do we simplify this? You have right? So this will become this one. You have to, I mean, I can't, I've seen many different forms of answers. I mean, I don't know how on earth you came up with those answers. I wonder, you know. I mean, it's when you simplify this, you get right? Sorry. So this is the correct form of this is the correct form of simplification for this is 1 here. I know quite a few of you got this correct, but I was surprised by the number of people who did not get this correct, you know, because this is nothing to do with statistics. This is something you should have learned before coming to this course, right? Okay. Okay, this is, all right. So that's quiz 7. Next one, all right. Today, as I said last week, I'm going to start talking about some other things, not because we are done with MLE for good or bad, but you will remember you will get MLEs in the exam. There will be at least 2 questions on MLEs, right? So please practice more questions. I mean, I've done enough. 10 questions is more than what I can do. I mean, no course in the university does 10 examples on one particular topic, right? So I feel I have done enough examples, right? It's just for you to now sit down and do some more examples by yourself, right? Okay? All right, guys. Today we're going to talk about a new topic, which is known as confidence intervals. Now, so far in this course, we've been talking about point estimation. Now, confidence intervals or confidence estimation, it doesn't give us just one answer. Like, for example, if you ask the question, what is the right? If you ask the question, what is the temperature now in this room, right, or in Manchester in general, I mean, the answer, I mean, the temperature varies from minute to minute, second to second, right? So if I say like it's 10 centigrade, that may not be an accurate answer, right? Okay. Whereas, so a possible answer could be 10C, right? But a better answer could be 10 plus or minus 0.2 C, right? So what you have here is not just one value, but an interval of values, right? So you have 10 plus or minus 0.2 is the same as 9.8 to 10.2. So here you have an interval estimate for the temperature in Manchester right now, okay? Because you cannot claim that the temperature at a specific day or specific hour is a fixed number. Obviously, it changes from second to second, right? So this answer is more plausible than this answer, right? So this is a point estimate, whereas this is an interval estimate, right? So in this course, in this section of this course, we're going to talk about how to construct so this is a point estimate. And this is an interval estimate. Okay? So in this section of the course, I'm going to talk about how to construct interval estimates, right? Okay? All right. So that's the purpose of the classes this week, right? And possibly also next week, we will talk about the same thing, right? Okay. You don't need to copy this down. Now, suppose all right, suppose you have data set, suppose you have a data x1 to xn coming from a distribution that is parameterized by theta, right? Okay. So the key word here is 100 times 1 minus alpha percent confidence interval denoted by this. Okay. So this is the formal definition of, this is P for probability. So the probability that the theta, the parameter theta, lies between L stands for the lower limit, U stands for the upper limit, right? So the probability that theta lies between these two is equal to 1 minus alpha, where alpha is a number between 0 and 1. So for example, if alpha is if alpha is 0.05, right? If alpha is 0.05, then we have a 95% confidence interval. So this thing here becomes 95%, right? Okay, so that's confidence. That's the definition of a confidence interval. Now the definition of a confidence limits the confidence limits are this and this. So this is known as the lower confidence limit, and this is known as the upper confidence limit. U for upper, L for lower, right? Okay. Right. So the next thing we need to define is something called or maybe I can write it down here. The coverage probability. The coverage probability is simply the probability that theta lies between L and U. Okay? And the next thing we need to define is the coverage length. The coverage length is the difference between the upper and the lower limits. So it's, in this case, it's simply U minus L. All right? So in other words, U in full all right? Okay, so this is known as the coverage length, right? The distance between the upper and the lower limits is known as the coverage length, right? Okay, guys, so there are four terms: confidence interval, confidence limits, coverage probability, and coverage length, right? Okay, the next thing, don't bother copying this down. Before I go to the next section, I need to talk about something called percentiles. You might have seen this before. Do you guys know what a percentile is? Yes? Oh, no. So, for example, take the you should take the normal distribution N01, I mean the standard normal. It looks something like this. I know my drawing is rubbish, but this is you should draw the density. You should draw the density of the standard normal. This is what you get, right? Now, the percentile is a point along the x-axis, right? So that there's an area to the left or right of it, right? So, for example, if you should take this point here, right? And suppose this area here is alpha, right? All right. Suppose the area that I shaded in red is alpha, right? Then this point here will be referred to as Z subscript alpha. So meaning that there is an area of alpha to the left of it, right? Okay. Now suppose, okay, let me draw another picture, maybe a better one, I don't know. suppose suppose you have this picture, right? This is 0, right? And suppose in this case you take 2 points, right? So that the area in between is, say, 1 minus alpha. All right? Okay? So the area between the 2 points is 1 minus alpha. Now, so these two areas would make up how much? Alpha, right? Because remember, the total area below a PDF must be 1, right? So if this area is 1 minus alpha, these two should make up alpha. So let's take this to make alpha by 2, and this to make alpha by 2, right? Okay? So the total area is 1 minus alpha plus alpha by 2 plus alpha by 2. So this point here over here will be, if you follow the notation here, this will be z 1 minus alpha by 2, and this point here will be z alpha by 2, right? You follow me? Yeah? I'm just following the notation that I used in the top figure. Whenever there's an area of alpha to the left-hand side, the point on the x-axis is referred to as z, little z subscript alpha. So following that notation, these 2 points will be this and this respectively. Okay? All right? That's for the normal distribution. Now, let's do the same, and by the way, because of symmetry, right? Because this is symmetric about 0, right? These 2 points will be the same. I mean, they are mirror images of each other. In other words, this is equal to minus of this, right? Okay? Number 2 is the student's t distribution, say TA. You remember we talked about this a while ago, student's t, right? And if you plot, are you listening, guys? Please. If you plot the PDF of a student t distribution, it will look something like, once again, my nasty pic. I apologize for not being able to draw anything. So this is the PDF of a student T looks more like it's kind of symmetric, right? Now, once again, if you take this area to be alpha, could you guys listen, please? If you take this area to be alpha, right, then the point on this axis, this point here, right, will be referred to as the percentile of a t distribution, which we denote by t, a, comma, alpha. So there are two subscripts. Little t, A is the degree of freedom, comma alpha, alpha is the area to the left, right? Okay. One more figure. Now let's take 2 points, one over here and one over here, such that this area, the area in between, this area is 1 minus alpha. All right? So if this area is 1 minus alpha, the area in the two tails will add up to alpha. So let's take these 2 points so that this area here is alpha by 2, and this area here is also alpha by 2. Okay? Are you with me? Okay? So, according to the definition of percentile in the top figure, this point here must be equal to t right? And this point here must be equal to t. You follow me? Right? Because there's an area of 1 minus alpha by 2 to the left of this point, and there's an area of alpha by 2 to the left of this point, right? And again, because the t distribution is symmetric around 0, right? These 2 points are mirror images of each other. In other words, t okay. All right, guys. Are you with me or not? Yeah? You guys okay? Yeah. All right, the next, number 3, is the chi-square distribution, which I'm going to talk about in a sec. The chi-square distribution is denoted like, this is the notation I used earlier. You may remember, we did all the normal distribution, t distribution, and the chi-square distribution. We did them way back in the course, right? Now, a density of a chi-square distribution, it looks something like this. It's easier to draw. So if you draw a density of a chi-squared, it will look something like this, right? Now, if you draw, once again, if you take a point over here, let's say, right, such that the area to the left, this area here, suppose this area is alpha, right? Then this point here will be chi-squared A alpha. So this is the notation I shall use. This notation corresponds to this point here, to the left of which you have an area of alpha, right? Okay. Now, suppose now Right? Suppose you have another picture where instead of just one, you have 2 points. Let's say this one and this one, right? And suppose the area in between these 2 points, this area here, is 1 minus alpha by 2, 1 minus alpha, right? Okay. Now, if this area is 1 minus alpha, the remaining area should be equal to alpha, right? So let's suppose that this area makes up alpha by 2, and this area here makes up alpha by 2, right? Okay. So according to the definition of this on the top figure, right, this point here must be chi-squared A 1 minus alpha by 2, because 1 minus alpha by 2 is the area to the left of this point, and this point here must be chi-squared A alpha by 2, right? But these 2 points are not equal because the chi-square distribution is not a symmetric distribution. The normal and the t distributions are symmetric, but the chi-square is not a symmetric distribution. It's a skewed, as you can see, it's a skewed distribution, right? Okay. So these two are no longer equal. Okay. All right. The reason I have done this percentile, so this is because I need them to do the confidence interval. So now I can go to the confidence intervals. All right. So I'm going to talk about now confidence intervals. Right, I'm going to talk about confidence interval for one sample, right? And the first one, number 1, the first one I'm going to talk about is the confidence interval for the population mean when the population variance is known, right? So I'm going to assume the following, all right? So you have, suppose right? So I'm assuming that we have IID data from a normal distribution. This is the population, mu is the population mean, sigma squared is the population variance, and we are assuming that the population variance is known. So we want to construct a confidence interval for mu, the population mean. Now, how do we do that? Now, let me test your memory. If you have IID from this, what can you say about the distribution of x bar? what distribution x bar will have? It will have a do you remember this or not? I mean, I mentioned this. Do you guys remember this? Yes? Yeah. Okay. If you don't remember, just look in the formula sheet. Right, it's there. Okay. Now, what distribution x bar minus mu will have? Okay, and I'm just trying to test your memory, guys. And what distribution will this have? N0, 1. Okay. Okay, so what this implies, guys, is that this guy here has a standard normal distribution. Now let's go back to the picture. You see the picture that I showed you a minute ago. Do you remember? Oh, man, what did I do? All right. Shh. Do you remember this picture, guys? Right? This is a picture of a standard normal density. Right? This is a picture of a standard normal density. And if you have 2 points, this point and this point, the area between them is 1 minus alpha. Right? Okay? Now we know that this guy here has a standard normal distribution. Therefore, using this picture, we can say that this is where the nice picture comes in, although my pictures don't look nice. Huh? Do you follow what I'm saying or no? Sorry. See, using the picture that you can see that the probability that this guy lies between this point and this point is equal to 1 minus alpha. Yes? Okay? All right. So let's take the picture away. All right? Okay. Now, this is the same as saying that the probability yeah. Okay. And this you can rearrange like this. This is the same as saying the probability that just give me a sec. Give me a sec. Oh, I left a z here. There should be a z alpha by 2 here. So do you see what I've done? All the statements here, this statement is equivalent to this statement is equivalent to this statement. Right? Now, this statement is equivalent to the probability that x bar minus right? That's because of the fact right? Okay, hence right? Are you guys with me or not? Do you follow the argument that why? Now, what I try to show you here, guys, is that how to construct a confidence interval for mu, assuming that sigma is known, right? So I started with the statement. I will go through it one more time if you did not follow. I started with this statement, which is one of the results we learned long time ago. This is the same as this statement, right? This is the same as this statement. And from this you can jump to this because of the picture that I showed you, right? Because of the picture I showed you that this implies this, right? And this is just a matter of rearranging it. You get this. And then some more rearrangement gives you this statement, right? From this to this you get after rearrangement. And you get this because of the fact that z alpha by 2 is minus of z 1 minus alpha by 2, right? And hence, finally, if you look at the definition, remember the definition of CI, which I gave you right at the beginning. This is the, I don't know, man, today is not a good day. Why I keep doing this? All right. Okay. Because of the definition of CI, which I gave right at the beginning of the class, which is, you may remember, this is the definition of a CI, okay, confidence interval. This interval here must be a confidence 100 times 1 minus alpha confidence interval for mu, right? So that's one. Don't go away yet. No, some of you are ready to pack, I know. Number 2, I'm going to talk about CI for population mean when all right, so first, number 1, I talked about confidence interval for population mean when the population variance is known. Now I'm going to talk about confidence interval for population mean when the population variance is unknown, right? So once again, suppose all right, with sigma squared unknown. So that's the crucial. Now, do you remember the T distribution we talked about some time ago? Right? One of the properties of the T distribution is that I gave you this property. Do you remember this property? What distribution does this have? Let me check your memory. Hello, guys. Do you remember this? What distribution? I gave this huh? Oh, come on. This is a property I talked about in the class some time back. You don't need to know this, but this is a property you need to know. I mean, it's something I mentioned in the class, right? Okay? Okay? So, using this, I will let you, all right. Using this, you can construct a confidence interval for mu, right? You should follow the same argument. I'm not gonna repeat it, right? You should follow the same by the same argument as for number 1, right? You can show that the following. S is, by the way, S is the sample standard deviation, right? And I don't expect you to know the proof for this. I don't expect you to know the proof. But if you can prove it, that's great. Yeah? Right? By following the same arguments as in number 1, you can show that this implies this, and hence right? Okay, so this is, the argument is very similar for number, but once again, I don't expect you to know how to prove this, but if you can prove it, that would be great. Right? On Thursday, I will talk more about confidence intervals and how to derive them. Right? I will mark all the quizzes this evening, and I will send it to you in a few hours' time. Okay? See you, man.
我操，你这头发有点骚啊，你知道吗？对。